Okay, so we're going to pick up where we left off, which was with this example here, and I'm seeing a product rule. So when I go to find my derivative, my first times the derivative of my second. Now the derivative of sine is cosine. The derivative of cosine is negative sine. So there's my first times the derivative of my second plus my second times derivative of the first. And really I just want to evaluate the derivative at pi over 4, so I don't need to go through and distribute here. I can just plug in pi over 4. So sine of pi over 4, root 2 over 2, times cosine of pi over 4 is also root 2 over 2, minus root 2 over 2, plus, this is root 2 over 2 plus root 2 over 2, times root 2 over 2. So luckily we don't have to think about too many evaluations. This is just 0. So 0 times anything is going to be 0. So that whole term is gone. And then I just have 2 root 2's over 2 times root 2 over 2. And that's just going to be root 2 times root 2 up top over 2 on the bottom, which is 1. So apparently the slope at pi over 4 is 1. Now to bring clarity to what we just did there, again I'm going to graph sine of x times, parentheses, the sine of x plus the cosine of x. And I'm looking specifically at pi over 4, so I'm going to make my window from 0 to pi over 2. And I'll count by pi over 4. It should just be in the middle. And I'll go from negative 2 to 2 just to look at that portion of the graph. And apparently at this point the slope will be 1. Which right here we have a slope of 1. Is what that's telling us. Okay? We would probably see it more clearly if we wrote the equation of the tangent line at that point. So if we use the slope of 1 and the point of pi over 4, 1, and wrote an equation for the line going through that point with that slope, we'd probably see more clearly that it was a tangent line. But at least we know it's positive because it's going up, and positive 1, we're going to trust our derivative. Okay, more practice on the bottom. You may want to try these on your own and then come back and look, or you can just watch them and then get your practice out of the homework at the bottom. On this first term, I'm going to rewrite first as s to the negative first minus 10 cosecant of s. So our derivative is, derivative of this is negative s to the negative second, and the derivative of this, the derivative of cosecant, where are we, is negative cosecant cotangent. So this is going to be negative 10 times negative cosecant s cotangent s. So this will be negative 1 over s squared. And this, when I multiply negative 10 times the negative cosecant cotangent, is going to be a positive 10 cosecant s cotangent s. I hate when they use s's, but they're not unavoidable. So there's our answer there. I would go with the quotient rule, bottom, times the derivative of the top. Secant is secant tan. Minus the top, times the derivative of the bottom is nicely just 1, all over bottom squared. So that's just x secant x tangent x minus secant x over x squared. You may see that secant x factored out, depends on the problem. Product rule, first and second functions. So our first times the derivative of our cosine is negative sine, plus the second times the derivative of sine is just cosine. So this becomes negative sine squared, and this becomes cosine squared. And that's it. We're done. You may see the use of a Pythagorean identity. So your answer, oddly, may not have a cosine in it. They may replace the cosine with 1 minus sine squared. And then the final answer would be 1 minus 2 sine squared. It's a possibility. Okay? They may also leave it like that, but just so you know, they may also change the sine squared into 1 minus cosine squared, and then have the full answer in terms of cosine squared. So there's many different versions of what could work as your final answer. And our last one, product rule. So first and second. So our first times the derivative of the cosine is negative sine, plus the second times the derivative of the first. Again, theta is like an x here, so the derivative of just x would be 1, the derivative of theta is just 1. And of course the derivative of 1 is 0. So we don't need to complete that polynomial. So we could distribute our negative sign, so it would be negative theta sine theta minus sine theta plus cosine theta. Okay, your homework is here at the bottom. And that's just due after break, and other than that, just have a good break.